Okay, so laws of exponents you learned in Algebra 1 and in Algebra 2. It's not new. Okay, and we're not taking it further than you learned it then. So hopefully this is at least looks familiar. So we have something like this. I want you to realize the big part is called your base. And the little part up high, top right, is called your exponent. So for example, if I have x squared, what's my base? And what's my exponent? Mm-hmm. Okay, so if you look at our first rule, it's power of 1. Don't let this throw you off. This is the easiest rule. Power of 1, anything with power of 1 is just itself. It's just like saying if I have b, that's the same thing as saying b to the first power. So if there is no power, it's the same thing as saying the power of 1. Yes? Okay. So if this whole thing is to the power of 1, does anything change? No. Does anybody remember the power of 0?
Yeah.
What does it equal?
0.
No. 1. Anything to the power of 0 equals 1. Okay? So, if this whole thing is to the power of 0, what does it equal? 1. Now, what does this equal? 2, because m to the 0 is 1 plus n to the 0 is 1, and that equals 2. Any questions with the power of 0? Okay, so now let's look at the product of bases. So we actually talked about this rule in our last unit. Okay, when you're multiplying, what do we do with our exponents? We add them. So this is the same thing as saying a to the m plus n. And the reason we add them is because if you have a to the third times a squared, well, that's 1, 2, 3 times 1, 2. Well, it just wants to know how many times you multiplied it. Well, if I multiply it 3 times 2 more times, how many times did I multiply it? 5. You just add how many times you multiplied. And it's because your exponent is your total number of times multiplied. So if you multiply 3 and then 2 more, that's 5 total. Okay, so you're adding your exponents. So if we look at this first example, we threw in a coefficient. Okay, coefficients, y'all, we still treat like normal. So technically, this could put a 1. What's 1 times 2? 2. Now what's m to the 5th times m to the 4th? 9. 9. 5 plus 4. Okay. Adding your exponents. So here, what's negative 3 times 4? Okay, and we have c cubed times c, which is how many times? C to the 4th, because remember, technically this is 1. And then d to the first power times d to the 4th power, which is what? D to the 5th. Now, this is just telling you, make sure you always write your answers in alphabetical order, okay? Your variables should always be in alphabetical order. Okay, I want y'all to try example 12. I'm going to give y'all a minute to try it. Okay, so this is what you should have gotten. Any questions with that? So 2 times -4 is -8. A times A 3 more times is A 4 times. C squared, C cubed, 3 plus 2 is 5. And this one didn't have the letter D here, did, so it's just once. Okay, so now let's look at quotient rule. So if we added when we multiplied, what do you think we do when we divide? We subtract. So it's proper, it's top exponent minus bottom exponent. However, if you read the bubble, it says instead of using the rule, think to yourself, where do I have more? So for example, if I have a squared over a to the 5th, well, that's 2 over 1, 2, 3, 4, 5. Where do I have more? On the bottom. So where's my a gonna stay? On bottom. And so if I cancel 2, how many do I have left on the bottom? 3. 5 minus 2 is 3. But can I leave the numerator empty? What can I put? 1. So that is why you always think about where there's more. So again, if I flipped this, a5 over a squared, where are there more? So a is going to stay on top, 2 cancel, and I'm left with 3. Now, do I have to have a denominator? No, so that's my answer. So looking at these two, where are there more? Top, and what's 11 minus 5? Looking at this one, where are there more? Bottom, so my n's going to stay on the bottom. What's 12 minus 9? And what goes in the numerator? 1. Okay, power to a power. We also talked about this rule in the last unit. Who remembers what we do with power to a power? Multiply. So it's am times n. Okay, so anytime you see parentheses, well, what do parentheses mean to us normally? Multiply. So that should be obvious. And the reason being is if I have x cubed to the 4th power, well, 4th power means 4 times. So x cubed 4 times. Do you really want to write things out that many times? Especially not if it's bigger. What's 3 plus 3? Plus 3. Plus 3. Well, what's 3 times 4? So was it easier just to multiply? Yeah. Now, you can have multiple bases. And when you have multiple bases with an exponent, you have to give that exponent to both bases. So what's 3 times 2? And what's 3 times 4? Now this one, does anything in here simplify on the inside of my parentheses? No. So we have a bunch of things on the inside that have to be squared. We have to square everything, even the coefficients. Now remember, coefficients we treat like normal. So what's 3 squared? 9. Remember, we're not multiplying with coefficients, we treat them like normal. However, if it was an exponent, you'd be right. Okay, so this is x to the 1st power, so what's 2 times 1? Now what's 4 squared?
6.
And then 2 times 2? 4. So remember, the coefficients you follow normal rules for. It's only the exponents that we're following the weird rules for. Right, Amir? Okay, last one is negative exponents. Okay, negative exponents are when you have an exponent on the wrong side of a fraction. So if it's not a fraction, you have to make it a fraction. So if you have a negative exponent on the top, you move it to the bottom and it becomes positive. If you have a negative exponent on the bottom, you move it to the top and it becomes positive. So looking here, what has the negative exponent? The 5 and the x, or just the x? Just the x. Okay, the difference would be if it looked like this. That would be the 5 and the x. If there's not parentheses, it's only what it's touching. Does that make sense? Okay, so knowing that, this has a negative exponent and needs to move. Now, it's not a fraction, so I'm going to draw my fraction bar, and I'm going to move it to the bottom. And when I move it to the bottom, it becomes positive 3. So my 5 stayed on top, and now I have x to the positive 3. There's my answer, because it doesn't simplify. Now, this one has, ooh, my elbow popped. Okay, this one has the whole thing with a negative exponent. So what do you think that whole thing has to do? Flip. So if I personally like to flip the whole thing when I have a negative on the outside. So let's flip it. And now I still have the squared, but it's positive now because I got rid of the negative by flipping the whole fraction. Okay, so knowing that, well, isn't 4 divided by 1 just 4? And what's 4 squared? Now, could I have done this one in the calculator? Why? You're right. This one could have been done in the calculator. Why? It has no x's. It has no variables. Okay, when there's no variables, y'all, do it in your calculator. Make your life easy. Okay, I mean, I showed you how to do it not in the calculator, but 4, type it the exact way you see it. And did we get the exact same answer? Now, it does cancel the parentheses for some reason. Don't do that. Type it with the parentheses. I don't know why it does that. But type it the exact way you see it, press enter, and that's your answer. Cool? Awesome. Okay, look at number 20. Well, what is 40 divided by 20? Let's start there. 2. Yeah, my zeros technically cancel. 4 divided by 2 is 2, which is a whole number, so it goes on top. Now, what do you notice we have a bunch of? Negatives. So I'm going to focus on moving negatives. I always like to move negatives first when it comes to my exponents. So I have this m to the negative 1. I'm going to move it to the bottom, and it becomes m to the positive 1. Now I have this m to the negative 6 on bottom, so when I move it to the top, it becomes positive 6. Now, I have that n to the 8 on top. Does that move? Why not? Yeah, because it's positive. It's not negative. So that stays on top. And then I have this n to the negative 9, so that has to move to the top. Everybody okay with what I've done so far? Just moved all my negatives. And now, again, we're going to follow one rule at a time. So I have 2. Now I'm going to look at my m's first. I'm just working it left to right. What rule am I going to follow here? I'm going to subtract because we're doing the division rule. So what's 6 minus 1? And where were there more, top or bottom? Top. So m stays on top, and we have 5 because 6 minus 1 is 5. Now, where are all my n's at? At the top. So do I even need a fraction anymore? No. And what do I do with these exponents? Add them together because now we're multiplying. They're on the same level. What's 8 plus 9? It's 17. Yeah. So there's your answer. Okay, so there's some on the back. I want you to try those. I'm going to take attendance, and then we're going to talk about them. But I want you to try them. Huh? Super quick. Okay, so if you look at number 18, what did you get? Negative 6m to the 6, because negative 3 times 2 is negative 6. 2 plus 4 is 6, so m to the 6th power. Now, is it okay if my coefficient's negative? Yes. What's the only thing that we have to move when it's negative? The exponent. Those are very different, okay? Look at number 19. So here we had 6, and then technically no other coefficient, so it's just 6. How many x's?
3.
How many y's? 3. And how many z's? 2. Okay, now 20 can be done in a bunch of different ways. Personally, I like to simplify my insides first if possible. Does the inside simplify? Yes. What's negative 6 divided by 3? Negative 2. And where are there more y's? Top. And what's 5 minus 2? And then z is on bottom. So now we have this. Everybody okay with that? Okay, now I have this negative, so I'm going to go ahead and flip everything. And now it's a positive 2, just like we did on that practice problem. And last but not least, I have to square everything on the inside. So what's z squared? Z squared, yeah. Now what's negative 2 squared? Positive 4. Negative 2 times negative 2 is positive 4. And what's 2 times 3? Now, there's a bunch of different ways you could have gone about this problem, and as long as you did it correctly, you would have gotten the same answer. The easiest way to do it, though, when you have parentheses is always simplify the inside first if possible, because if not, you had way more to square and bigger numbers to deal with, okay? Okay, so let's look at number 21. What did y'all get? Well, what rule do y'all want to follow first? You want to get rid of to the 0 power, or do you want to get rid of power to a power? 0 power? Okay, what's p to the 0 power? 1. So I have 1 r to the 5th to the 6th power. Well, what's 1 to the 6th power? 1. And what's 5 times 6? Do I have to put the 1 in front of my r? No, so my answer is just r to the 30th power. What if you would have followed power to a power rule first? Well, what's 6 times 0? 0. And what's 5 times 6? And p to the 0 is 1. And then again, you don't have to put the 1, so you get r to the 30th. So it doesn't matter which rule you followed first. Okay? Just remember, though, a lot of people last period were wanting to do 6 times 1. It's 1 to the 6th power. Okay? Very, very different. Okay, what about 22? Does anything inside my parentheses simplify? No, so let's just cube everything. What's 3 cubed? 27. And now how many m's? 15. And how many n's? Perfect. Okay, this last one can be a little weird, but it has parentheses, and before I can combine across, we have to get rid of those parentheses, so we have to do power to a power first, because nothing inside my parentheses simplifies. So what's 3 times 4? And what's 3 times 5? Now I'm getting rid of the parentheses, but this technically means multiply, right? And then what is 2 times 2? Now what I want you to realize is when you multiply fractions, you're just multiplying across. Well, these aren't the same, so you can draw your line or you can rewrite it. When you have a lot of letters, I always recommend rewriting it because it makes the order easier when you're simplifying division. Now this one, you would have been fine to just draw your line across and subtract, but when you have a bunch of letters with a bunch of work left, it's easier to rewrite in alphabetical order. So where are there more A's? Top. And what's 12 minus 4? 8. Where are there more C's? Bottom. And how many are left?